Welcome to video lesson 10.1 and 10.3. I'm combining both of them into one here. The concept is exploring conic sections and the circle, and you are going to need some graph paper for this one. So if you don't have graph paper, go get some. Okay, here is box number 1 of the 6 boxes. Let's just start by exploring what conic sections are. So I have a picture here for you. And a conic section is just a curve that you get by intersecting a plane and a double cone. So notice I have like cones that are stacked up on top of each other here. By changing the inclination of the plane, you can get either a circle, a parabola, an ellipse, or a hyperbola. So notice I've got circle, ellipse, parabola, and hyperbola here. We are going to talk about the circle and we're going to talk about the ellipse. We're not going to talk about the parabola because we've already talked about that extensively in Algebra 1 and Algebra 2, and we are going to talk about the hyperbola here. So again, a conic section is nothing more than the intersection of a plane and 2 cones. So like right here, like this is where the circle comes from. Right here, if you tilt the plane, you get the ellipse. The parabola is if you cut one of them with perpendicular to a base, but not parallel to the midsection here like you would get for a hyperbola. A hyperbola and a parabola are different shapes, so that's important to know. But anyways, this is what a conic section is, and we'll be talking more about it extensively. And today we're going to talk a lot about the circle. Okay, here's box number 2, and here's what I would like you to do. On graph paper, I want you to graph the following points on graph paper, and then I want you to think about the lines of symmetry that you see for each one. So take a moment. Here's A, here's B. The video is going to pause in just a second. I want you to graph each of these points, -5, 0, -4, +3, and -4, -3. So there's 2 sets of points there. I want you to draw a picture for A and a picture for B, and I want you to answer the following questions that come up, okay? Okay, in box number 3, we're going to talk all about the circle. So let me give you the definition first, and then I'll try and point out all these parts that are in the picture to match the words of the definition. So the definition for us right away here is going to be the set of all the points, x's and y. So every single x and y, it's a collection of points in the plane that are a distance r from a given point called the center. Okay, so if you look at the picture here, the set of all the points. So what I'm doing is I'm talking about all these points right here that are an equal distance. So there is literally an infinite amount of points if you go around the circle. But if we take each one individually, it counts as an x and a y. They are a certain distance r away from a center point, which in this case happens to be the origin. Okay, so that's the picture. There are 2 basic equations that we need to know when we talk about the circle. The first one here, number 1, is if the center is at the origin, like it is in this picture here, right? So you can kind of see over here that the center is at the origin. Well, if the center is at the origin, then the equation that we're going to use is x squared plus y squared is r squared. R represents the radius of the circle. X and y are 2 given points. So x squared plus y squared equals r squared. The second kind of equation that we need to know for a circle is if the center is not at the origin, but the center is somewhere else. And we call somewhere else h comma k. H comma k is going to be where the center is. And notice that it's just x minus h squared plus y minus k squared is r squared. So the only difference between the first and second equation is the center is at hk for the second one, and it's at 0, 0 for the first one. And notice if you plugged in a 0, 0 for this one down here, you would end up with that one up there. So that might help you guys. Okay, so make sure we have all this in our notes, and then we're going to start using it in the next couple of boxes. Okay, here's box number 4. We want to write the equation of the following circles. So I have A, and then I have B, which I'm going to do with you, and then part C is going to be a you try over here on the right hand side. So let's take a look at part A. The center is at 0, 0. I noticed that. So I know I'm going to have an x squared plus a y squared equals r squared. So the only thing I have to figure out, you guys, is the r squared. So check it out. The radius is 2. So this is going to be x squared plus y squared is equal to the number 4 because the radius is 2 units, and when I square that, I get 4. So that's the equation for part A. That one's pretty easy. Let's take a look at part B. The first thing you're going to want to do is you're going to want to find the center. And I think the center is here. And so the center is located at the point 4, -1. This is acting like the h, and this is acting like the k. And then the radius, which is 1, 2, 3, the radius is equal to 3. So I have all the information that I need. So I'm going to do x minus h squared plus y minus k squared is equal to r squared. So the equation is going to be x, let's see here, minus h, so x minus 4 squared plus, this is going to be y plus 1 squared is now equal to 9, because 3 squared is equal to 9. So notice that x minus h, so that x minus 4, so that moves it 4 to the right, and then a plus 1, right? Since my k is negative, I go minus a minus 1 gives me the plus 1, and then quantity squared is equal to 9. So there's the equation for that one right there. And part C is going to be the U try, okay? So here you go. I'm going to move this over. And I want you guys to do the exact same thing that I just did here. Find the equation for this circle given to you right here. Okay, hopefully you got the right answer of x plus 1 squared plus the quantity of y minus 2 squared is equal to 4. So the first thing I did was I found my center, which was located at -1, 2. I found my radius, which is equal to 2, and then I plugged into the equation x minus h squared plus y minus k squared is equal to r squared. Okay, hopefully that makes some sense to you. Okay, box number 5, we're going to find the center and the radius for each of the two equations given to you here. Notice that A and B look very different. That's why there's a red star next to B. It's very different. The procedure is a little bit different. Let's start with the easy one though, okay? So notice that this is already in the form of x minus h squared plus y minus k squared is equal to r squared. So the center is going to be at h comma k. So the center then for me is going to be at 16 comma -9. So notice that those signs are different, right? Because it's x minus h. So therefore it's going to be a 16 and then a -9 because a minus would give me that positive there. And then r is going to be the square root of 144, which in this case, of course, is 12. We don't need to worry about the negative square root here because it can't have a negative distance for a radius. Okay, this one looks different though. Take a look. The problem is that this one does not look like this one, so I can't just read off my h and my k and my r. But what I can do is I can do a procedure called completing the square and get it to look like that. So here's how you do it. So I'm going to take all of my x's and put them together. So x squared plus 8x plus I'm going to leave some space to complete that square. And then plus y squared minus 10y. And then I'm going to leave some space to complete the square equals 8 plus whatever the first thing I added right here, this guy, I have to add to the other side. Plus whatever the first thing I added over here, I got to add to the other side, okay, to keep my equation balanced. So the question is, what number goes here? So we do half of b squared. So half of 8 is 4. 4 squared is 16. So 16 goes there and 16 goes there. And then I got to figure out, okay, what is half of -10 is -5 squared. So 25 goes there and 25 goes there. So now when I'm all said and done here, when I break this down, this is going to become an x plus 4 quantity squared plus this is going to be a y minus 5 quantity squared. Let me get rid of that line for you. Okay. And then on the other side, I'm going to get 8 and 16 and 25, which is equal to 49. Okay. So now I'm in really good shape. So what I did was I turned this part into a perfect square trinomial, and I turned this part into a perfect square trinomial. And if you need to review how that works, we can go over it in class. I can give you some examples. But basically all we're doing is completing the square on both the x and the y variables. So now I can clearly see that my center is going to be this is acting like the h and this is acting like the k. So it's going to be -4, 5, and my radius is going to be the square root of 49 or the number 7. Okay, so again, this is called completing the square, so CTS, and it's a process by which you can determine the center and the radius of a circle given the information presented this way. Okay, last and final box, number 6, it's a you try. Tell me the center and the radius of the given equation right here. Okay, hopefully you got the right answer. The center is located at -8, -3, and the radius is at 11. So it's -8 because we take the opposite sign inside our equation, which is already set up as the standard form for a circle with a radius of 11. Okay, there you go.